Alright, now we're going to take a look at scope, which in the local variable scope. Alright, so let's see. So you remember the let syntax. It was like this: A5, B3, and then so this is a list of all the little bindings that we've made, and then we can use them within the rest of this let statement. So we can do like plus A, B, and you close that off. Alright, now this plus A, B part is called the body, and this other part is called the just the list of variables. The list of bindings is this part, and this is called the body. Alright, now the body is what gets returned from the let statement. So it returns 8. Now if we did this again, we could just put whatever we wanted in the body. It doesn't actually have to use these variables at all. So we could just do that and see it would use that. So what this does is it will define A to 5, B to 3, and then it will execute the body, and whenever the body comes into a variable, it will look up and see, oh, is there an A, and what does it equal to? And if it finds it in here, then it will say, oh, well, that's 5, and it will put it as that, and then it'll do the same with B. Now let's try this. Define A24. So A is now defined globally as 24. So what happens if we run this thing again? Well, we get 8 again, and we do get 8 because it looks first at its local bindings, at the nearest local bindings, which is this, and it finds that A equals 5, and because it finds that, it doesn't look onto the global ones. Now let's say we define, put this again here, oops, but this time go in and change this to like AZZ. Oops. AZA. Alright, now it's going to look here and it's not going to find A, so it's AZA instead, and then it's going to keep looking and find that A equals 24, so we should get 24 plus 3, which is 27. Alright, so that's pretty simple to understand, I hope. Now let's look up here at a let statement. Let's say we've got let A equals 5, B equals 3. And then within the body of this let statement, let's say we've got another let statement that has z owner x equal to 4 and y equal to 1. Now that's pretty easy. I think you can probably guess what it's going to do. If you do plus A, well, yes, let's do plus A, B, X, Y. And I think you know that's, well, it doesn't do much. Okay, 13. So the answer 13, because it's 5 plus 3 plus 4. 5 plus 4 is 9, plus another 4 is 13. Okay, so this makes sense. First, it looks for A in this table here, X and Y, and it doesn't find it, so it looks at it here again to this one, and it finds it. And if it didn't find it there, it would look again, and if it still couldn't find it, then it would do an error. But it did find it. Alright, then same with B, and then X and Y, it goes up here and looks at these. And what happens if we do this? We define X up here as equal to 99. Alright, so now we've got X equal to 99 in this let statement, and then in the body of this let statement we're redefining X to equal to 4. So which one is it going to choose? This body. So this body is part of this let statement, which is the body of this let statement. So it always looks in the most local table, the most local bindings table to find the value. So when it gets to X here, it's going to look up this one and see that X equals 4, and it won't bother to look at this one and see that it's equal to 99. So we should get the same answer that we had before, 13. Alright, then but what if we want to define these ones, use these ones in our next let statement? So we could do this. We could do like let x equals plus a and b. Alright, then run that. But not yet. Okay, so x equals a and b, which is 8. So we should get another, well, I don't know what we're going to get, but let's see. 17. So we get 5 plus 3 is 8. That's a and b. And then another 8 is 16, plus one more is 17 from y. Alright, now let's be a little bit trickier here. So a and b, when we define this, it looked inside this table here and found that found a in this table and b in that table. But what if we did this? A plus x. Well, let's just make it even simpler. Let's just do x. Let's bind x to x. Okay, so when we're binding x here, it's not actually bound yet. It's still trying to evaluate what this side is. So it will evaluate this x by trying to find out what the value of x is, and it will look in this table first, up here, and find that x is equal to 99, and then it will bind that to this local x down here, and that will be it. So it's 108. And just to prove to you that it's like that, this x is using that x and not that x, I'll add 2 to it. Alright, so this should give us 110. Alright. Now let me now what about this? What if so you've got x defined up there is 101 basically. Then what about down here if we define z to equal plus x 5. Let's just put this down. What is z going to equal? Is that right? Yes. Alright, so the real question is here, does z look at this x, or does it look up at this x here? And I'm going to run it here and just show you what it does. So if it looks at this x, then the answer should be 101, and if it looks at this one, then it should be 99. Oops. 104. Right. Well, so we see that it looks at this x here. Oh no, we don't. No. That's right. Good. Okay, I thought that it did. I thought that I was wrong, but I'm right. Okay, so this is x plus 5. So if it's bound to that x, then that's 99 plus 5, which is 104. So it's bound to this x. And then if it had been bound to this one, then it would have been 100 and whatever that is, 106. So we can show that. Just put that one to xx, and that to x. Oh, actually, it won't be able to find that one. Just give me an error. Yes. All right. Okay. So let's get rid of that. Okay. So in a let statement, you can't access the other variables that are in the same binding list, because actually the let statement doesn't specify what order they're going to be bound in, and so you can't have x referencing itself in here. Suppose you did a function, you couldn't have it call itself recursively, and you can't have these other ones call previous ones. But there is a way you can do that by using the let star statement. Alright, then we'll run this, and this time z is going to be bound to this x, so the answer should be whatever that is. I said it before, I think 106. Yes, 106. So this just means that it gets evaluated in order. So this X will get evaluated, and then this C will get evaluated, and then that Y will get evaluated, and you can use the ones in the same list. And next up, I'll show you how to define it so that you can actually access yourself. So Y could access like Y, well, if it were a function, it could call itself recursively. But I'll show you that in the next episode.